So hi friends, I am Madhyalakam. So I am going to explain about the hidden Markov model experiment 4. So how to do it. So just I'm going to explain that. So let's start. So I'm going to explain that implementations of hidden Markov models. So these are the steps to follow. So we are going to find the sequence of hidden state by the known sequence of observations using hidden Markov models. So consider two hidden states, sunny, rainy, with observation states happy and sad. So we are having a table like sunny, rainy, and so in the with the observation state happy and sad. So with that explanations, with that examples, we are going to explain that hidden Markov's law according to that algorithm. So first step what we are going to do is define the transition matrix which specify the probabilities of transitioning from one hidden state to another. So second step what we are doing is that define the emission matrix with specifies the probabilities of observing each possible observations given each hidden states. So third step, define the initial probabilities which specify the probabilities of starting in each possible hidden stage. So step 4, define the observation sequences with the sequence of observation needs to be analyzed. Step 5, initialize the alpha matrix with zeros where each row is represented at time steps and each column represented a possible hidden state. Step 6, calculate the first row of the alpha matrix by multiplying the initial probabilities by the emission probabilities for the first observations. Loop through the rest of the observation sequences and calculate the rest of the alpha matrix by multiplying the emission probabilities by the sum of product of previous rows of alpha matrix and corresponding row of transition matrix. Calculate the probabilities of observing sequences by summing the last row of the alpha matrix. Find the most likely sequence of hidden state by selecting the hidden state with the highest probabilities at each time step based on the alpha matrix அப்படின்றது சொல்கிறாங்க. So first we are going to see that program. So first we will import numpy as mp, and first we need to know the transition matrix. So we used to show that in array format. So np.array, the following numbers are that, and the emission matrix. So emission matrix arrays and the initial probabilities arrays and the observation sequences arrays all have been mentioned. And now we are going to find that if alpha is equal to np.zeros, then observation sequence, then initial probabilities. So first we need to observe the sequence each by line and the initial probabilities, and okay, then we are going to multiply the matrix from the initial to the emission matrix. And so if we are taking a range and we mentioning at t, so and again taking a value j in range, and we are arranging the observation sequence and the initial probabilities and the alpha, and then we are joining the two and making a sum of probabilities to do. So next finding the probability sums and print the probabilities of observation sequence and is probability. So before we found that have to be mentioned in print. So most likely sequence, again we have to take a range for the observation sequence, and we mentioned that if alpha is t comma 0 greater than alpha t1, that is 0 is greater than 1, most likely sequence appended one, it will be sunny or it will be rainy. So that 0 greater than 1, if it is a 0 greater than 1, it will be sunny or it will be rainy. So we need to print that most likely sequence of weather states. Okay, that is the probability. So thank you.